Percentage error, we know the formula is experimental value minus the accepted value divided by the accepted value times 100. Whenever we are talking about a percentage error that is too high or too low, we are going to be using a positive or a negative sign. For example, in the example that we talked about in class, if we're trying to guess the number of marbles that are in the jar, and we guess that the number of marbles was 104, then our percentage is going to be below the number of actual marbles that we have. How do we know that? Because our experimental value is lower than the actual value. So we'll calculate the percentage error. So 104 minus 141 is going to be an absolute value, divided by 141 times 100, it's going to give us 26.2%. Because it is below the actual number that we're looking for, then we're going to be using a negative sign to indicate that it's a percentage error that's lower than the actual number. If we guess that the number of marbles that were in the jar was 200, that means it's above the actual number that we have, then our percentage error is going to be a positive. We're going to be marking it with a positive. So I'm going to do here the calculation. And this number gave us that we were 41.8% off of the right number, which is 141 marbles. Because it's way off or above it, we're going to mark it with a positive number. So let's do this with an example that would pertain to chemistry or the lab. The example says, a student weighed an object on her balance and recorded a mass of 24.21 grams. Her teacher told her that her balance was giving her a rating 33.22% too high. So this will indicate that our percentage, we're going to be doing a positive sign. What was the actual mass of the object? So what we have here is we have the percentage error. We have the 24.21 grams, which is the experimental. We have the 100. What we're looking for is the accepted value. So I'm going to use the letter X to go into the accepted value. So if we're looking at, let's say, we have a graph here, and we got that it's 24.21 grams. We are way too high, 33.22% too high. So that means that our actual value should be lower than the 24.21. So we are off here. There's the 33.22% off that we are. Okay, so we're above the actual number. That means that we're going to be using a positive sign for the percent error. So in this case, we have our percent error is 33.22%. The experimental value is 24.21. We don't know the accepted value of either one of these numbers, so I'm going to put an X instead of the accepted, and then we have here times 100. The first thing that I'm going to do is I'm going to change this, and I am going to be dividing this number by 100. So we have 0.3322 equals 24.21 minus X divided by X. Now I need to put the X, this one that is dividing, I need to bring it to the other side. Because it is dividing, I'm going to be using the opposite sign, which the opposite of dividing is multiplying. So I'm going to bring this X multiplying up to this side. So I'm going to have 0.3322X equals 24.21 minus X. I need to bring x's on the same side, so I'm going to bring this one right here. I'm going to bring it to this side. This x is subtracting the 24.21, so I'm going to bring it using the opposite sign. So in this case, if it's subtracting, I'm going to bring it to this side, adding. 0.3322x plus x equals 24.21. Now I put these two together, and I'm going to have 1.3322x equals 24.21. What I'm trying to do is getting this x alone, which is my accepted value, which is what I am looking for. What is the actual mass, the accepted mass of the object? So I'm going to be, because this is multiplying, I am going to be dividing 1.3322. I'm going to bring it to this side, dividing the 24.21. And then we calculate that, and it's going to be giving us 18.17. So that is my actual mass. That is what I should have gotten here, 18.17. To check my answer and to see that I got the correct mass for this object, I can substitute this number that I got and insert it right here in the formula that we had. So the percent error, let's say that we don't know that. We're checking that our answer is correct. Our experimental value was 24.21 minus the 18.17 divided by 18.17 times 100, and my percent error should give me 33.22%. The previous example was when a percentage error was too high. Now we're going to be doing one that it's too low. At a lab, a student recorded a boiling point of 50 degrees Celsius on his data sheet. His classmates told him that he was 30.8% too low. Because it's too low, we're going to be using a negative sign in the percent error. In the boiling point, he just recorded. What is the correct boiling point of the liquid he was working with in the lab? So in this case, we're also trying to find the accepted value. We have the experimental, and we have the percent error, and we have the 100. So if we had same, this is the value that we're looking for, and we had 50 degrees Celsius, and this is a 30.8% difference too low. So we're going to be substituting these values into our equation, and we're going to be using a negative sign for percent error. So we have 30.8%, we're going to be using a negative sign. We're going to be using experimental, which is 50 degrees. I'm going to be using an x for accepted value times 100. To change this from percent into a decimal, we're going to be dividing by this 100 that we have here. So we're going to change this to 0.308. Negative. Don't forget the negative sign. This is still absolute value. So now I'm going to be bringing this x to the other side. Because it is dividing the whole equation on the top, I'm going to be multiplying minus 0.308 times x. Then I'm going to be bringing this x to the other side. We have to have them on both sides on the same, both x's on the same side. And because this one is subtracting, I'm going to be passing this one adding onto the other side. One of them is negative, one of them is positive, so they subtract each other, and it gives me 0.692 x equals 50. I'm trying to get the value of x. Because 0.692 is multiplying x, I'm going to be bringing this into a division. So I'm going to divide 50 divided by 0.692, and my answer should be 72.25. This is the degrees Celsius that are part of the accepted value. To check my answer, I am going to be substituting this number as my accepted value, and I am going to be leaving this one as an unknown. So I want to find out the percent error, and I have 50 minus 72.25 divided by 72.25. This is an absolute value times 100. My answer is going to give me my 0.3079, which I round to 0.08, then I multiply it by 100, which is going to give me the percentage 30.8%, which is the same that I got here. Because we know our experimental value was lower than our accepted value, we need to write down a negative sign to our percent error, indicating that it is too low. So as a summary, if our percent error is too high, we are going to be using a positive sign, and if our percent error is too low, we are going to be using a negative sign to indicate that. Let me know if you have any questions.